What is the Sun actually? It is the heart of our solar system, a massive sphere of hot plasma that has been burning for billions of years. It is the source of all light and heat for the planets in its orbit, and without its energy, life on Earth would be impossible. But what is the Sun, exactly? How big is it? How hot is it? And how does it produce its incredible energy every single day? The numbers are so vast they can be hard to imagine, so let's use some everyday comparisons to understand the story of the Sun. The basics: distance, size, and mass. Let's start with the fundamentals. The Sun is, on average, about 93 million miles, 150 million kilometers, away from Earth. This distance is so fundamental to astronomy that it is used as a standard unit of measurement, called an astronomical unit, or AU. Light from the Sun, traveling at 186,000 miles per second, takes about 8 minutes to reach us. To put that distance in perspective, if you could drive a car to the Sun at 60 miles per hour, it would take you nearly 177 years to get there, driving non-stop. If you were flying in a commercial jet, it would take about 19 years. In terms of size, the Sun is the largest object in our solar system by a wide margin. Its diameter is about 865,000 miles, 1.4 million kilometers. This is roughly 109 times the diameter of Earth. To visualize that, you could line up 109 Earths across the face of the Sun. Its volume is even more staggering. You could fit approximately 1.3 million Earths inside the Sun. Here's another analogy: if you scaled the Earth down to the size of a standard marble, the Sun would be the size of a giant yoga ball, about 3 feet in diameter. And that yoga ball would be about a mile away from your marble. Its mass is equally mind-boggling. The Sun has a mass of about 1.989 times 10 to the power of 30 kilograms. That number is so large it's hard to grasp. It is nearly 333,000 times the mass of Earth. To put it another way, the Sun contains 99.86% of all the mass in the entire solar system. All the planets, moons, asteroids, and comets combined make up less than 0.14% of the leftover mass. Because of this immense gravity, the Sun holds the entire solar system in its grip. Composition and structure. The Sun is not a solid body. It is a huge ball of gas and plasma, which is a super-hot, electrically charged state of matter. Its composition is relatively simple. By mass, the Sun is about 70.6% hydrogen and 27.4% helium. The remaining 2% is made up of trace amounts of other elements like oxygen, carbon, nitrogen, neon, and iron. Think of it this way: the Sun is like a giant, self-contained hydrogen bomb that has been continuously exploding for 4.5 billion years, but in a very controlled way. The Sun has several distinct layers. At its center is the core, where the Sun's energy is produced. Surrounding the core is the radiative zone, where energy slowly travels outward. Above that is the convection zone, where hot plasma rises and cools before sinking back down, like boiling water in a pot. The visible surface we see from Earth is called the photosphere. Above the photosphere are the chromosphere and then the corona, the Sun's expansive outer atmosphere. Part 3, the engine, how the Sun produces heat. Narrator: the Sun's immense energy is generated by a process called nuclear fusion, which occurs in its core. The core is under incredible pressure and has a temperature of about 15 million degrees Celsius, 27 million degrees Fahrenheit. At these extreme conditions, hydrogen gas becomes plasma, and the nuclei of hydrogen atoms are forced to collide and fuse together. Specifically, 4 hydrogen nuclei fuse to form one helium nucleus. However, the mass of the resulting helium nucleus is slightly less than the mass of the 4 original hydrogen nuclei. This lost mass is converted into a tremendous amount of energy, as described by Einstein's famous equation, E equals mc squared. This energy is released as heat and light. The temperature profile, from core to corona. The Sun's temperature varies dramatically depending on the layer. The core is the hottest region, at around 15 million degrees Celsius. As you move outward, the temperature drops. The photosphere, the visible surface, has a temperature of about 5,500 degrees Celsius 10,000 degrees Fahrenheit. To put that in perspective, the hottest temperature ever recorded on Earth was 56.7 degrees Celsius 134 degrees Fahrenheit in Death Valley, California. The Sun's surface is about 100 times hotter than that. Even the coolest parts of the Sun, the sunspots, are still around 3,000 to 4,500 degrees Celsius, hot enough to melt any known material. But then, something strange happens. As you move further out into the Sun's atmosphere, the temperature begins to rise again. The chromosphere is hotter than the photosphere, and the corona, the outermost layer, reaches temperatures of over 2 million degrees Celsius, 3.5 million degrees Fahrenheit. This is one of the Sun's biggest mysteries. Why is the atmosphere so much hotter than the surface? Some scientists compare the Sun to fried ice cream. The outside is much hotter than the inside surface. This differential rotation, combined with the Sun's internal magnetic field, drives an 11-year cycle of activity. During this cycle, dark, cooler patches called sunspots appear on the photosphere. The number of sunspots increases and decreases over the 11-year period. At the peak of the cycle, known as the solar maximum, the Sun is more likely to produce violent eruptions called solar flares and coronal mass ejections. These events release huge amounts of energy and charged particles into space, which can impact satellites and power grids on Earth. Think of it like this: the Sun has a heartbeat, and that heartbeat is an 11-year cycle of magnetic activity. When the Sun is active, it can have solar storms that are like cosmic hurricanes, sending blasts of energy our way. The Sun is a star of staggering scale and power. It is 93 million miles away, yet its gravity holds us in orbit. It is a ball of plasma with a mass 333,000 times that of Earth. Its core is a nuclear furnace at 15 million degrees Celsius, fusing 600 million tons of hydrogen every second to produce the light and heat that makes all life on Earth possible. It is a dynamic, rotating, and ever-changing engine, and its story is written in its data. By using everyday comparisons, we can begin to grasp the truly awesome nature of our nearest star.